Okay, ready? So today is the 4th, isn't it? Thank you. Okay, let's look at another problem like negative 3x squared minus 12x minus 12. We're asked to factor this, and we start by asking ourselves, what is it?
Or rational.
There is no ratio, so it cannot be irrational.
Oh,
So it's a trinomial. We're asked to factor it. It has 3 terms. And since it's a trinomial, I identified it correctly. The next step in line is it in descending order? The next question is it in descending order?
Yes.
Perfect. Does it have a greatest common factor?
Yes.
Does it have a negative leading coefficient?
Yes.
Good. So what do I pull out?
The negative 3.
Good. What is left in parentheses? And how many terms will I put?
I have 3 terms.
Exactly. I start with 3. I have to have 3. Awesome.
X squared minus x.
Very carefully.
Oh, so it'd be plus and plus. Plus x plus. Yep. Yep.
Good. Very good. And now I'm asking myself, is this a special product? And how do I think about it? And what is my thinking process? My thinking process is always to look at the first and the last term and identify whether they are perfect squares. Would you say that x squared and 4 are perfect squares?
Yes.
Good. So then you will say, my assessment is that I have what?
Then x plus 2. O squared.
Good. So the only thing is that I skipped something very important.
You have to double check your middle.
I have to check the middle term. We reviewed this formula 2 weeks ago, the first day of classes. What is the middle term when I expand this? 2 times the first times the second. What is it? The middle term.
So it's a difference.
2 times the first times the second. 2 times the
AB.
first times the second. 2 times x times 2. Right, write it down. You don't have to do it. Indeed, 4x. Because it is, because the middle term is 4x, now I check, is this 4x?
Yes.
So then I will say this is correct.
But that would be the answer. That would be 3x plus 2.
The factored, completely factored form of this is this. Very good. Let's look at one more. What about a squared plus 6a plus 9? What is it? What type of polynomial is it? Trinomial. Is it in descending order?
Is that an A or 9?
Everything is a and 9, yes.
That is a 9. Okay.
So this is a 9 and this is an a. I'm so sorry.
No, it's okay.
I'm standing while I write, so bear with me. A squared, it's in the packet. Do you have the packet? I just picked it from there. So you know where it is.
Oh, okay.
So a squared plus 6a plus 9. That's exactly where you open it. You just open it. It's right there, right here.
Okay.
Just make a sign, make a note on it so you know that where it's coming from, and when you go back, you can redo the, I mean, you can look at them, or you're not going to be able to finish each and every problem there.
Okay.
Okay, so it is a trinomial. It's in descending order.
Yes.
Greatest common factor. Greatest common factor. Is there anything I can pull out from all 3?
No.
No. Negative leading coefficient.
No.
Okay. Special product.
Yeah.
I hope for what?
A plus 2. That's right.
Good. But what is the middle term when I expand this? How many terms do I get when I expand this?
6x.
I get 3 terms. When I square binomial, I get 3 terms. We wrote that 2 weeks ago.
A binomial square is A. It's a trinomial.
It's a trinomial. Excellent. So what will be the middle term when I expand this?
6x.
6a. Do I have 6a here?
Yes.
Therefore, this is the correct form. From the formulas that we reviewed 2 weeks ago. 2 times the first times the second. The first term squared plus 2 times the first times the second is 6a plus the second term squared is 9. Please review those because we're always going to go back to Adam and Eve. Yes, Bree, go ahead.
No, I'm saying I know this, but you're just doing it different. But it's fine.
I'm fine with any method.
No, I actually forgot the method. But now I know what you're trying to do though.
Very good.
I know what you are doing, but I have to.
Very good. If I can do anything else to help you, let me know at any point in time. So let's move on to the next one. Like, for example, m squared plus 13m plus 42. So now we're asked to factor this polynomial. I have to identify what it is. Remember, you have to redo all these problems before you attempt the homework, as many times as you need till you are able to reproduce this on your own, by yourself. Okay, is it in descending order?
Yes.
First of all, is it a trinomial?
Yes.
Is it in descending order?
Yes.
Greatest common factor?
No.
No.
Negative leading coefficient?
No.
Special product?
No.
No, because 42 is not a perfect square. Excellent. So therefore, I have to move on to the next method, which has 1 as the leading coefficient. So I have to find two numbers whose sum is this number with a sign in front of it, and whose product, exactly, whose product is this number with a sign in front of it. So this will always be the product, and this will always be the sum, as long as this number is 1. So Mallory already gave us, she said 6 and 7. The numbers that we are finding, 6 and 7, when we add them, we get 13. When we multiply them, we get 42. There are no other two numbers. No one can find different numbers whose product is 42 and whose sum is 13. Therefore, now we know what the factored form of this polynomial is. And what is it?
What's the variable?
I'm sorry, m.
Okay,
M.
so it would be m plus 6 and plus 7.
Oh, I wrote X. Put that out.
It doesn't matter if you want to put x, please put x. It's not important. Any variable you want. Very good. Let's look at x squared minus 20 minus x. Okay. So what type of polynomial is it?
Trinomial.
Is it in descending order? Very good. So then this is x squared minus x minus 20 equals 0. Any common factor? Greatest common factor here? No. Negative leading coefficient?
No.
No. And now we are looking for two numbers whose product is? Very good. And whose sum is?
-1.
Excellent. So let's think of two numbers. So here's what you have to remember. Here's what you have to remember. Whenever the product is negative, one number is positive and one number is negative. The sum is negative. Oops, it doesn't appear there. The sum is negative. Therefore, the larger number, the stronger in absolute value, has to be negative. You cannot say -4 and 5. That would not work.
No,
No,
it's
that's
-4.
-5 and +4 indeed. So then, can anyone give us the factored form of this?
X minus 5, x plus 1.
Very good. It will take you less than 10 seconds to check this. X times x is x squared. +4x minus 5x is -x. -5 times 4 is -20. Any questions? Any questions? Very good. Let's also look at x squared plus 13x plus 36. I forgot here and I want to go back for a moment. Is this a special product?
No.
Because -20 is not a perfect square. X squared is a perfect square, but -20 is not. Agreed?
Yeah.
Perfect. Awesome. Good. So let's go back to this one. So x squared plus 13x plus 36. What type of polynomial is it?
It's a trinomial.
Very good. Is it in descending order?
Yes.
Yes.
Negative leading coefficient?
Nope.
Greatest common factor?
No.
Special product?
Yes.
Good. Because this is a a perfect square. This is a perfect square. So what will you say?
X plus 6 squared.
However, it's not done till I check the,
Middle term.
excellent. What would be the middle term here?
12x.
Is this 12x? No. So then I'm looking for two numbers whose product is,
36.
very good, and whose sum is,
13.
can we find two numbers whose product is 36 and whose sum is positive 13? Awesome. You guys are the best. So then the factor form will be,
X plus 4x plus 9.
great, great job. I think we're ready for the very last step. So let me go back and refresh your memory again. What type it is? Descending order, greatest common factor, negative leading coefficient, which can be both at the same time. We already talked about binomials. I see cell phones under the table. I see them from here. 1, 2, 3, 4 possibilities here, but only two special products on the trinomial. And we already discussed this a minute ago. A trinomial that is not a special product and the leading coefficient is 1. Now we are here at the very bottom, the most difficult situation in trinomials. Ready? Ready?
Yep.
Okay, so back on this page, I'm going to start with a C, 4x squared minus 4x minus 15. Okay, what is it?
The trinomial.
Is it in descending order?
Yeah.
Yeah.
Greatest common factor?
No.
Special negative leading coefficient?
No.
Special product?
No.
1 as the leading coefficient?
No.
No. Excellent. Nothing worked. This is the last chance. At this time, we are going to look at two numbers whose sum that does not change is still negative 4. But this time, the product will no longer be just this. It will be exactly the product of these two, which is negative 60. 4 times negative 15 is negative 60. So now I'm looking for two numbers whose sum is negative 4 and whose product is negative 60. I always start with the product. If the product is negative, I'm looking for a positive and a negative. And the sum is negative, which means the negative number takes over. So here's what I would do. Every time the product starts becoming larger number. So it's 60, and 60 is 6 times 10. Well, 6 is 2 times 3, and 10 is 2 times 5. These are prime numbers. This is the prime factorization of 60 that we learned in arithmetic. So 2 times 2 times 3 times 5. Using all these numbers, I want to come up with two factors. One that is negative and one that is positive, so that when I multiply them, I get negative 60. But they should be 4 distance apart, because I want the sum to be negative 4. So let's try to find two numbers. Here's what I would do. I would say 10 and 15, 4 and 15. Now, the sum is not negative 4. Then I would say 12 and 5. 12 and 5, the sum is not negative 4. Then I would say 10 and 6. Yeah. 10 and 6. But which one is negative and which one is positive? I have to be very careful because the sum is negative 4. And that's it. Now, please pay attention to the next step, because the next step is not x minus 10 times x plus 6. It's not. It's not, because the leading coefficient is not 1. So at this stage, I'm going to rewrite the problem as 4x squared minus 10x plus 6x minus 15. So what I did was, I replaced this negative 4x using the numbers that I just found out. The sum is negative 4. The product is negative 60. These are the only numbers that work. But at this stage, because the leading coefficient is not 1, I cannot get directly to the factored form. There is another intermediate step. I replace -4 by -10 plus -10x plus 6x. These are the numbers that you gave me. And I didn't change the problem. -10x plus 6x is still -4x. However, what do we always do with 4 terms? Exactly. What do we always do with 4 terms? Exactly. Thank you for that. So then, please tell me, what will you factor out from the first 2? What is left in parentheses?
2x minus 5.
What do I have to have? Do not look. What do I have to have coming out from the other 2? Otherwise, I will not be able to continue.
A 2 and a 3.
What do I have to have coming out of the other? I'm sorry?
-3 times -3.
I don't care about that. I'm only asking because I need you to understand what I'm trying to do. If I don't get a 2x minus 5 identical, I will not be able to continue. I'm sorry? I didn't get there yet. I'm only asking, what do I have to have in parentheses coming from the other 2? Otherwise, I can't continue. This is crucial to understand.
Okay.
Because I already heard the 2x plus 5.
Because she's gonna pull up.
If you don't write it ahead of time, you may make a mistake. That's why please don't look and write it first. And now please figure out, I need a sign. In a moment, this is our first example. This is our first example. I will get to more in a minute. So I want a sign and I want a factor. I need a sign and I need the factor.
Plus.
Perfect. Exactly. 3 times 2x is 6x and 3 times -5 is -15. So now what is the common factor that you will pull out coming out of these 2 terms?
2x minus 5.
Indeed, 2x minus 5 is the common factor. And then what will you have in parentheses? Yes. I do not ask you to make adjustments to what you know. I'm only asking you to see if this is an improvement. If it's not an improvement, use your own method.
So,
Yes.
to be clear, when you start factoring by grouping the 4x, but not being grouped, as soon as you get whatever the 2x minus 5 would be.
I copy it because otherwise I'll make a mistake.
Okay.
Is it me? I
No,
hope not.
it was mine. I made
Okay,
it wrong.
okay. Good, as long as it's not mine. I'm fine. Okay, next problem. Let's go back. Let's say 6y squared minus y minus 1. Ready?
Which one do we just use with the A will be in common?
Okay, we are right here at the top. So we did this. 6y squared minus y minus 1. What is it?
Trinomial.
Is it in descending order?
Yeah.
Negative leading coefficient?
No.
Special product? No. Because 6y squared is not a perfect square, -1. The last term cannot even be negative. Good. Is 1 the leading coefficient? No. So then we are looking for 2 numbers whose product is?
6.
Careful, very careful.
-6.
Thank you. And whose sum is?
-1.
Excellent.
6.
I forgot to carry it.
So can anyone give us 2 numbers whose product is -6 and whose sum is -1?
-3 and +2.
Indeed, -3 and 2. So can anyone tell us how to rewrite the problem now?
6y squared
Awesome.
minus 3. Y.
Yes.
Y
Yes.
minus 1.
Excellent. We did not change the problem. We only replaced -y by -3y plus 2y. Okay, 4 terms. If you go back and combine them, you're not going to get anywhere. If you combine like terms and going backwards, you're not going to get anywhere. So now we move forward by factoring by grouping. From the first 2, what will you factor out?
3y.
What is left in parentheses?
Y minus 1.
What do I have to have in parentheses?
2y minus
Come on.
Only now I look, not before I write. Again, Make adjustments if they are improving your method. If they are not improving your method, forget them. So what do I have to write? Plus? Very good. Good. So now what is the common factor that I have to pull out?
2y minus
What is left in parentheses, please?
3y
3y
plus
plus
1.
1.
That's it. It takes less than 10 seconds to check. 2y times 3y is 6y squared. Positive 2y minus 3y is negative y. Negative 1 times 1 is negative 1. Okay, one more. Let's say 2x squared plus x plus 1. What is it? Descending order? Greatest common factor? Negative leading coefficient?
No.
Special product. Remember, I sound like a broken record, my apologies, but you have to go through these steps because if you miss something, if it's a special product, it will take you 5 minutes instead of 30 seconds. So please do not skip any of those steps. Good. So special product not. 1 is the leading coefficient? No. So then we are looking for two numbers whose product is?
2.
Excellent. And whose sum is?
1.
Good. Can we find two numbers whose product is 2 and whose sum is 1?
2 and 1.
Okay. So is 2 plus 1 1? No. Okay.
Oh, shit. Negative. Okay.
You cannot have any negative because the product is positive. We can't have any negative.
So you okay, no. So there's no factor.
That's not
You can't
factor.
use a negative and try to find it.
The sum, the product is positive. You cannot have any of the numbers to be negative because the product is positive. Yep.
Why would it be negative 2 plus 1?
But negative 2 plus 1 is negative 1.
Right, okay.
And negative 2 times 1 will be negative 2. Very good. Okay, next.
Wait, so like, can't solve it, so like, just solve it.
It's not solve. It's we're not asked to solve. This is not an equation. We're asked to factor. It's not factorable. Not all polynomials are factorable. Yep, not all polynomials are factorable. We wish where they were, but they are not. Okay, final step, polynomials. So let's look at 2x cubed minus 6x squared plus x minus 3. So what is it?
It's a polynomial.
Good. Descending order,
Yes.
greatest common factor,
No.
negative leading coefficient.
No.
Good. So I can only say I can only say factoring by grouping. There is nothing else. I cannot say anything else. So what will you factor out from the first two?
2x squared.
Very good. What is left in parentheses? Excellent. Thank you. Are you making stuff up or you tell me what to write in parentheses? Very good. X minus 3. And what do I have to have from the other two before I even look? I completely agree. Good. So now what do we have? I need a sign and a factor.
Plus 1 plus 1.
Very good. Do you all agree with plus 1? Excellent. Common factor? Excellent. And in parentheses? Good.
I have one question.
Please. Any question?
We did x minus 3 because we still had to use that the exponent of 3. Is that why we did x minus 3?
2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared.
Oh, okay, right. That is 6x. Okay.
Better?
Yeah.
Perfect. Other questions here? Okay, so now the factoring homework has to be done between now and Wednesday. So the factoring in my math lab should be done. If you encounter any difficulties, you should bring the problems to class. Okay? So we can finalize that and put it behind us. So by now, we should be finished with 1.1, 1.2, and plus factoring in my math lab. All these three should be done, everything, for full credit between now and Wednesday. Also, I want to see those 7 problems from the supplement on Wednesday.
The one you asked for.
Yes, the 2 or 3 problems that we did in class. I think we did 3 in class. And the other 4, I need to see them. You don't have to turn them in, but I will walk around and you will show me 7 problems. Yes?
This is kind of general about, I guess, what you've done so far in the class. The steps that you follow, if you keep repeating, and you're saying how like they make like I don't know, like the difference, like it can make a difference. Yeah. So like how long it can be. I don't know what better. I would
With a strategy?
yeah.
Oh, you're not going to know what practice. Because if I give you now a binomial, you don't know the strategy to apply. You're not going to If I give you a trinomial, if you try to apply the strategy from the binomial or the one from the polynomial, it's not going to work. One of your colleagues is asking a question. Please, please, please. One of your colleagues is asking a question. Allow me to answer. So that's why I split them in 3 categories. If you don't understand the difference between those 3, you may not be able to factor them. First, you have to fit what you are asked to factor into one of the 3 categories and follow the steps. Otherwise, you run into difficulties. Now, if you know a totally different method than the one I presented in class, use it. Whatever works for you, I'm fine. As long as you know how to factor, it doesn't matter. But this is the correct way. You have to separate them into 3 different categories. If you don't separate them, you'll have difficulties from the beginning. Once you know what you're factoring, then you will know what strategy to apply. Because they're different. They have different special products. Binomials are separate, different than trinomials. They are factored differently. And they have special products that are different. The first one has 4, the second one has 2. And the second one has 2 other methods. One with the 1 as a leading coefficient, and the last one with anything else but 1. They're totally different. All of them are different. Did I answer your question? Was this the question?
Yeah.
Why did we separate them? Because they're all different. Okay, very good. Other questions? Yes, please. See?
Do we have a test schedule?
Yes, it's scheduled, but it doesn't mean that it's good. It's carved in stone.
Okay.
I will announce it, but we are not there yet. We have to get to chapter 2. We are, yes. Yes, go ahead. The test will be announced. We will agree on it on the date. We have to finish the material. I've done nothing so far, really. From the material for test 1, it's probably 1%.
Don't we have a quiz before the test?
All the quizzes are in my math lab. You have to keep up with those quizzes as well. The quizzes are in my math lab. They are all, everything is assigned already, but I'm not finished. I didn't finish the material to get there. This is all you have for now.
Are you going to let us know when the quiz is?
Yes, I will let you know. Yes. Other questions for me? Okay, back now to 1.5. So now we have accomplished in 1.5, there are 4 different methods of solving quadratic equations. We finished with factoring. This was our first method from section 1.5. It continues with taking square roots. So this is another method. It's a very specific method. It is applied only when, and only a very special situation, and the special situation has to look like this. X squared equals a number.
So are we in the book now? We just write.
We are back in 1.5 with the second method of solving quadratic equations. So taking square roots is our second method. The first one was factoring, and we used almost 2 sessions to discuss factoring. I hope that now we remember the 3 special products from the first day. I hope now that we know how to factor all these 3 types of polynomials: binomials, trinomials, and polynomials. Moving forward, I hope that we put this behind us. But it needs a lot of practice. So don't expect to say, oh, we're done, I understand it, I know it. If you don't practice, you'll forget. Okay, so if the equation, it's quadratic, and it looks like this, meaning some quantity with x, not just plain x, but some quantity with x squared and a number on the other side, we're allowed to take square roots. And it is recommended in this case. The answer from here will be x equals plus or minus the square root of k. So let me just give you a first very simple example with x squared equals 4. If I want to solve this equation using factoring, I will have to move 4 to the other side and factor. It's a special product. It's a binomial. It's in descending order. No greatest common factor, no negative leading coefficient, a special product. Can anyone give us a special product on this? Very good. And the two answers are, because it's quadratic, I have to have two answers. X equals? Very, oops, exactly. Perfect. However, for this particular situation, we can also use the taking square roots method. So let's do just that. So back to the same problem, I can take the square root and I will write plus or minus the square root of 4. But how much is the square root of 4? So then this is plus or minus 2. I ask my students sometimes, and they say that the square root of 4 is plus or minus 2. That is incorrect. The square root of 4 is only positive 2. But then where does this plus or minus, where do they come from? No. No, the plus or minus come from this side. So the square root of x squared is basically the absolute value of x. But we skip this step. So instead of writing the equation like this should be the correct steps. X squared equals 4. I'm asked to solve this. I take the square root. I write the left-hand side is the absolute value of x. I write the correct, the square root of 4 is 2 on the other side. And this is an absolute value equation. So which numbers have the distance? Remember, the absolute value is the distance from 0. Which numbers can I have in here? Well, I can have 2, and the answer is 2. But I can also have correct. However, we like to skip this step, and we go ahead directly to write x plus or minus 2. The point I'm making here is, I'm kindly asking you to remember that the square root of 4 is not plus or minus 2. The square root of 4 is only 2. The plus or minus do not come from this side, but from that side, from the absolute value. Okay? So please remember that and not ever say that the square root of 4 is plus or minus 2 because we write plus or minus 2 here. Okay, so let's look at a few more examples. I know I have 5 minutes left or so. So let's say x plus 12, everything squared equals 100. You can say, why don't I expand the left-hand side? How many terms will I get when I expand x plus 12? If you say 2, it tells me that you did not review what we did during the first day of class. 3. Yes. So a binomial squared is a trinomial. I mean, we have to remember this. Please. So, however, this is a typical situation. I will not expand, but I will use the taking square roots. This is already set up like that. So then, taking the square root from the left and from the right, the left-hand side is x plus 12. I should write the absolute value. Instead, I write plus or minus on the other side, which is excellent. Of course, I have to solve now. This is linear. And I have x equals negative 12 plus or minus 10. And I do have to separate. I do have to write what they mean. And what do they mean? Well, negative 10 plus 10 indeed is negative 2. And negative 12 minus 10 indeed is negative 22. So this is the method of taking square roots. But only if only if I encounter a situation like this, something with x squared and only a number on the other side. If it's 5x, no, I cannot use the taking square roots. So that's the required. Something with x squared and on the other side a plain number. It can be 0, it can be positive, it can be negative, but it has to be a plain number, no x. Very good. So now here's the third method. Let's start it.
So that's the answer, right? X negative 2 and X negative 20 plus the minus both of them. That's the answer.
Correct. Correct. So let's look at completing the square. Now you can say, or you can ask, wait a minute, do I really need 4 methods? Do I need to learn 4 methods of solving quadratic equations? And the answer is yes. Here's why. The factoring, if it happens to be a 10-second, half a minute situation, always factor. Always factor. If it's not factorable, and if it's set up like this, of course I'm going to use the taking square roots method because it's so easy. Now, when do I ever use complete the square? The answer is never, unless I am forced to use it. If the problem says you must use complete the square, then will use complete the square. The fourth method, because I only have 1 minute, I may not be able to even start this. The fourth method is quadratic formula. So out of these 4 methods, which one do you think is not applicable always? Let me refresh your memory. Factoring, taking square roots, complete the square that I haven't shown yet, and the quadratic formula, which we should know, but I will review it with you. Which of these 4 methods is not always applicable? Factoring indeed. Factoring is the only one that cannot be applied in all situations because we know not all polynomials are factorable. All the other 3 methods will always be applicable. Complete the square, taking square roots after I complete the square, and quadratic formula. So I would like you to start working on 1.5 because you're going to have some parts of factoring and some parts of taking square roots. But you do